well, it's a challenge for the next session, and therefore we could not have the next data space here. This is like the climax of what's happening. Therefore, we will have a look and reflect how we can write more of these success stories. And a lot of all these great developments are stimulated via research and innovation actions, and well, on European level. And therefore, the next session is called IDS as catalyst in projects. And what we want to say is, well, in research projects, because, well, a lot of these projects have been stimulated via research projects where a lot of groundwork has been done, networks have been created, the right expertise has been pooled, and then it can grow and move closer to the market, to the different industry sectors and so on. So therefore, I'm more than happy to have really a great lineup of people which well, have a strong footprint in European research and innovation. We will have representatives from some of the very big and influential projects on European level. We have a representative from the European Commission, so those who have to even think further. So what will happen in 10 years so that we can take the right measures. And this is Max Lemke from European Commission, DG Connect. He's strongly committed to IDSA since years. And Max, it's always well, a pleasure and an honor to work together with you. And it's great that you are with us.
Thank you.
And I hope you could witness what is the result of what you are stimulating with your colleagues. And it was impressive what has, well, happened in the last years. And yeah, so it's not me to talk about this. My dear colleague, Sergio Gusmeroli, he will guide us through this session. Sergio, well, he's a dear colleague. We know us since years now. And well, he really knows what's going on in Europe, and it's great to have him in the really inner circle of IDSA. And so Sergio Gusmeroli from Politecnico di Milano, from Italy, well, he knows everything about data and data spaces. So he's the perfect moderator. And well, I think that's all to say. Sergio, it's really great to see you. Thanks that you are with us. And with that, I will hand over to you. The stage is yours.
Thank you so much, Lars, and thank you for your kind introduction. I will be very brief because this is the last session of this exciting event. And what is this session about? Is IDS as catalyst in project as catalyst for data spaces. In one sentence, I would say that how current projects, I see Horizon 2020 projects, especially those who belong to the BDVA DIRO PPP, could contribute to the success of data spaces. And this is very important, especially in the Digital Europe program perspective. I think everybody is speaking about data spaces in Digital Europe, but the point is that we need to prepare, to pave the way for projects to be born in Digital Europe. And this means that Digital Europe is not research and innovation. Digital Europe is deployment, is capacity building. And so we need research and innovation at the moment in Horizon 2020, but in the near future in Horizon Europe program, in order to pave the way towards the real deployment of data spaces in Digital Europe. And so my message is that it is very, very important to know what the projects are doing now in Horizon 2020, because they will be those environments, those catalysts for innovation, which will prepare the so-called embryonic data spaces. and to have embryonic data spaces that will be fully deployed in Digital Europe. And we will have here after the introduction of Max Lemke, the European Commission, DG Connect, we will have 4 examples of projects. We have Chiara speaking about Musketeer, Martin speaking about i3 Market, Benjamin speaking about trusts, and Juanjo speaking I for Trust. And I believe that that's enough for my introduction. And I leave the floor to Max Lemke for his 10 minutes speech. Thank you.
Thanks, Sergio. I'm just trying now to share before we start. Can you now see my presentation? Can you confirm that you see my presentation?
You can see.
Yes, go on.
Thank you. Thank you very much, and thank you for the nice words, Lars and Sergio. What I was planning to do is, you will hear about projects from the speakers after me. So I give you a bit the direction where Europe is and give you the framework, and then you can see and ask your questions at some point how you are engaged in that. So Sergio has said rightly, research projects and research and innovation projects, or I would even call them innovation projects, because they're much closer to the market, are very important for paving the ground towards data spaces and towards European infrastructures. And I can only mention projects like in the agricultural sector, IOF 2020, Atlas Demeter, that were much more than 50 million euros, and they are still running for another 2 or 3 years. So they built the baseline for these data spaces because they are on the adoption of digital concretely in sectors. There's interconnect in the energy sector at the interface to the mobility and smart building sector. So as well there, bringing things together through the Internet of Things, bringing the data together in concrete applications and looking at platforms for these application sectors, or better, for these verticals. Same in manufacturing, we have numerous projects in manufacturing on that. And from there, the important thing is to bridge to the capacity building, to the deployment, as Sergio has explained, to build the European data spaces. So you would ask the question, what has Europe to do in that? We see space building up, as Reinhard Achers, for example, has shown in his last session. So I want to go a little bit into a bit more on that one in the couple of minutes I've left. Before I do that, I would like to make one thing that is very important for you as wanting to do research, innovation, deployment projects. Never lose policy and regulation out of your sight. So I think it's very important to look at the overall we, Europe, want to achieve, and also what are the legislative and regulatory instruments we have at hand. So when you look, for example, at the European Strategy of Data as the legal instruments, there is a list of 5 communications by the Commission that are planned to be ratified through this Commission. So in the next couple of years. And I think they built the framework, the regulatory and legal framework for anything that is done on data, like the Data Governance Act that looks at fostering the availability of data for use, the transparency and accountability framework for online platforms. Transparency is an important point here. Or the Digital Market Act, ensuring that gatekeepers don't undermine functioning the marketplace. So you know what we have in mind. So we don't want to see unfair behavior by owning amount of data and being unfair in that sense and triggering behavior that undermines the functioning and more. So I wanted to just give you the idea, and you can look into those details. I cannot do that in my 10 minutes. And now, if I see the legal and regulatory framework, I would like to come to the other side, which is the implementation, the deployment, building of what we are doing right now in research and innovation projects. And you hear more about. We aim to create a single European data space by having 9 common European data spaces in strategic sectors. And I'll give you 3 examples a bit later. So it will have a systemic impact on the ecosystem and will provide a rich pool of data in these sectors, but across the sectors, because you can imagine mobility, energy, electromobility and energy, they are, for example, very closely linked. So we have we create a horizontal framework for data governance in Europe and support these data spaces through the Digital Europe program. And look at the lower box, I think the most important point is also what is data without computing. So we also look at providing a marketplace for cloud to edge based services. And the Germans among you will say, okay, the first one is IDSA, the second one is Gaia X. And I would say, indeed, IDSA and Gaia X are important initiatives in Europe that will lead to this European data spaces and also to the European cloud to edge-based service infrastructure. They are important ingredients of that, and in some areas leading the way, but there are also other initiatives and in other industries that go in a similar direction, and on a European level we try to bring them together. Now if you look at the data spaces, we have around, let's say, between 8 and 20 million or so available for each individual one. So you will ask yourself the question, what can we do with 8 million? Peanuts. No, it's not peanuts, because what we want to do on Europe, we don't want to bring all the data together in place. What we want to do is we want to establish the links so there is an access possibility in a secure and trusted way to data for the ones who have a right to use them. So I would summarize that in a word. I always use the word glue. So on European level, we can only provide the glue. And if I give you 3 very quick examples, data sharing in the agro-food sector, when you look at the green box at the bottom here, you have many data spaces already available, farm management systems, B2B ecosystem by certain vendors who already work together, national, regional data hubs, high-value data sets from the public. So they are all there. So we need to, but they are not used in a shared way. So we need to encourage sharing and pooling of public and private data and the application of the data. So first of all, we need to motivate. So for private data, there is a first good experience in agriculture leading in that way towards the other sectors, because there's a code of conduct on agricultural data sharing that has been agreed. And we are looking for technical solution, obviously, and what I see coming out of projects like IDSA and Gaia X, we see technical solutions coming up that efficiently support the trustworthy data sharing. And we need those data platforms, and in particular, we need the right spirit for the actors to share, to be prepared, and to see the value of sharing. And in that sense, when you look at that, we have a lot of things that still have to be defined, like private versus public purpose of these data spaces, interoperability mechanisms, role of public data, and what is the contribution to the common good. So what do we have in common? What's the common good in public of the unclear for us is also some of the governance. It has to be by sector. So there are many framing conditions that are still open, and we can build on certain experiences, like I said, on the code of conduct. So in agriculture, we will do that in the Digital Europe program, and we'll have an agricultural data space in the next work program to come. Details are to come in the next, I would say, in the next months. European mobility data space, very, very, very similar issues. We have the policy, the Green Deal, and the digital decade, the 2 policies. Important, in particular, the strategy for data and the sustainable and smart mobility strategy. Support will be done in the Digital Europe program, and same 2021-22. And most important point I would like to highlight here is the similar one like we saw in agriculture. We built the glue, and we built on existing or emerging data spaces at all levels, European Union, member state, regional. And I have in mind what I see, Datenraummobilität. Herr Streibich has mentioned that in the previous one, Catenary X, the automotive network, and many more that are emerging across Europe. So we have to see how we can build the glue. And the same is true in the energy domain. In the energy domain, it's for easy data access and exchange, which we need for competitive markets for energy services. Here we have a slightly different support. We do the first step, the preparation, establishing the grounds for a common EU energy data space in Horizon Europe. Advantage is here we have 32 million euro available. So we have a lot more money available to build, but we are a bit earlier in the technology readiness level, a bit further away from the market. And then in 2023, we also plan under Digital Europe to do the implementation. So in general, I could say on these three and on several others, prepare. So we have a first phase where we prepare the data space on a European scale, how to bring the different initiatives together. In a second phase, we would implement. I think what is very helpful in this respect, I would like to promote the Open DEI position paper, Design Principles for Data Spaces. I think it's an excellent starting position. It's a deliverable of a Horizon 2020 coordination and support action program for open digitizing European industry. It was just published, and it's essential because it's a broad approach across European data space initiatives. There were key experts, key organization, key projects involved, always two-digit numbers in each of them, and they built on the large-scale pilots that I was mentioning in the beginning. So it's really build work that builds on clear routes that we have through our research. And what is the special thing about this is that they take a cross-sector approach, looking at manufacturing, energy, agri-food, and healthcare, and see what they have in common to find common principle. I find this is the most comprehensive first approach for design principles, but also for certain building blocks for soft infrastructure. And it also includes some reflections on governance. I'm not saying that this is what we will have to adopt, but I'm saying this is a good contribution to what we have to now bring together on a European level. So as next possible steps here, I see feedback, endorsement on these principles. So that means horizontally across sectors, but also in individual sectors through working groups in sectors, for example, through industrial associations and so on, through in projects like Gaia X, but also in European projects. Another one is maturing, piloting, but also contributing to the EU capacity building activities that I have mentioned in a minute ago. And last not least, also think of whether we could broaden such design principles to include more sectors. I have in mind, for example, the mobility sector, which is pretty prominent and I think very important to be included in this industrial approach, because the design principles for the data spaces here driven by industry. I would say this document is in particular valid for industrial data spaces as compared to more public applications. But I'm not saying it's not valid for that one, but it's made for the more industrial ones. So with that, I would like to finish, and thank you very much for your attention.
Okay, thank you very much, Max, for your comprehensive introduction. And yes, now let's open the eye, because the acronym OpenDI also means to open our eyes to what projects are doing. And we are starting now opening our eyes to Musketeer and Chiara Napione from Comau. The floor is yours, Chiara.
Hi, thanks. Can you see my screen? I think yes.
Yes.
So good afternoon. I am Chiara Napione. I work in Comau, which is a multinational company of industrial automation partner in the European funded project Musketeer. First of all, a short overview of the project. It lasts 3 years and it is going to finish at the end of 2021. We are 11 partners from 7 different countries, of which 3 universities and 8 industrial partners. The objective of the project is the creation of a platform of federated machine learning, but I will enter in more details later. Before, I prefer to tell you a story where we face a real problem. In this way, I think it will be easier to understand the importance of such a platform. I'm going to introduce you a manufacturing scenario about predictive maintenance where Comau and Stellantis are involved. The image shows a little part of a Stellantis production line designed by Comau. Imagine that a downtime in a plant costs from 30,000 euros per minute. And this easily explains why now preventive maintenance is being used. As you can see, the amount of machineries is incredibly huge, and naturally all these elements produce some data. Analyzing and studying them can boost the development of predictive maintenance. And now let's see the use case story. Stellantis plants are full of welding robots. Imagine that each car, your car, has more than 3,000 welding points. And obviously the quality of each point is very important for various reasons. Not enough accurate welding points can cause an inconsistency with design dimensions or a non-fulfillment of functionality and strength requirements, or simply they don't reach the needed appearance quality level. The challenge, therefore, is to improve welding point quality to reduce production waste and maintenance costs. We would like to build a classification algorithm trained on as much data as possible, able to recognize defects on welding points. So let's see how we can create this data set. Here you can see a production plant with the production line provided by welding robots. The welding robot records for each single point some welding parameters, such as the current between the electrodes, the resistance, and so on. Then on the right, we see that some of those pieces are sampled from the line to make an ultrasonic non-destructive testing for evaluating spot welding quality. The inspection consists of a manual testing made by an operator who classifies the points into different quality categories. The dataset has to be composed by the combination of both these welding parameter data and the quality test results. The problem is that in a production line, less than 1% of produced pieces are sampled and verified. And secondly, the manual test on each piece is not done for each welding point, but it is limited to a few critical welding points. Therefore, only a scarce percentage of points, less than 1 in 10,000, are subject to the quality control. What we want to do is to collect this manual ultrasound testing data and combine them with the welding data provided by the robot in order to train an algorithm that will be able to classify the welding points using only data coming from the welding robots. In this way, we will be able to evaluate the quality of each single welding point, so the 100% of points. To do this, unfortunately, we face some obstacles. First of all, machine learning needs a huge amount of data to work in the proper way. But in industrial sector, there are limited fault data, also because of preventive maintenance. Or, as we have just seen in our case, we have few data because samples from manual testing represents a minimal percentage. And this is a big problem, since the more data you have, more accurate will be the model. A solution can be to train the model on different data sets coming also from other factories. But this leads to other obstacles that are the one that we are solving with Musketeer platform. For example, the available data are not shared by companies to protect the trade secrets and personal information. And then we also have to consider that algorithms with large quantity of data are labor-intensive and time-consuming. That means that companies would have to acquire the appropriate hardwares. So the challenge goes from a technical point of view to the cybersecurity one, to the legal one, and others associated. Now I show you how we try to overcome these obstacles. We solve the problem of few data involving more plants and even more companies, obviously in a completely secure way. Making this example of the welding use case, all the plants have their welding robots and perform the quality test. Then they locally store the data and locally perform the machine learning model. In a second phase, some coefficients of these models are shared to the platform. But be careful, these coefficients are very different from the raw data and don't contain any business or personal information. Then the platform combines these models with a more accurate one. And finally, this improved model is sent back to the participants that can use it to better classify their welding points. This concept is the reason of the name of the project, that is Musketeer. And the motto is one for all, because each participant puts the knowledge of its data at disposal to train the global model, and all for one, because the improved model can be used by each single participant. So in details, what does this project do? It enables the sharing of data between enterprises in the sense that we have just seen. It allows the creation of better machine learning model for a win solution for everyone. Then this platform is distributed, secure, scalable, and privacy preserving. And now, why has the platform to be secure? Machine learning algorithms are vulnerable and can be objective of attackers who can operate in different ways. For example, they can compromise data collection, and this means that they can incorrectly label data, like, for example, saying that the quality of a welding point is good if it is not. But this is possible also in a very sophisticated way. A typical method is to change some pixels in a picture before uploading. And here, for example, adding some noise to the picture representing a panda, the image recognition system fails and classifies it as a picture of a monkey. And this adversarial attack is very sophisticated, as can fool humans. Another type of attack happens when the system behaves normally for regular data, but performs badly for specific inputs chosen by the attacker. For example, here, the normal photo is perfectly labeled as a stop sign, while the second, that has this yellow square on it, it is classified as a speed limit sign. And in this project, we also work to avoid this type of attacks. Then, the platform incentives the participation through data monetization. And this is also an important aspect, because if you provide your data knowledge, you will be remunerated because you are contributing to improve the model robustness. And this concept passes through the data value estimation. The platform is able to assign a score to each participant based on the content of its dataset. If its data makes the model more accurate, it will reach an higher value and will be remunerated more. And then, last but not least, it meets legal requirements. And I can assure that there are a lot of legal aspects to face. Now, if you want to learn more about our project, please visit our exhibition booth or our website. Thank you for the opportunity to present the Musketeer project and for your attention. Have a good continuation.
Thank you so much, Chiara. And so we started from the manufacturing domain. Then we proceed with the I3 market. Martin, are you ready?
Yes, can you hear me well?
Yes.
Very good. So I'm sharing just my screen now. Please confirm you see the slides.
Yes,
which is the first one.
Perfect.
Perfect. Okay, thank you, Sergio, and thank you, everybody, for the time at this late in the day. What I will just focus is in the activities that we are doing in the context of the I3 market project. I am Martin Serrano. I am the coordinator of the project, and I work for the National University of Ireland in a research center called Insight. And our main capabilities are in stream processing, intelligent systems, and IoT. I would like to start my intervention with some reflections, right? So there is some perceptions that we have learned today and yesterday that a data space is an homogeneous area or virtual space where existing data structures might coexist, and there is a discoverable and explorable activities that can be done towards queries or towards accessing the data. And most important, that data space has an infinite storage. This is one perception I have been discussed with experts as well. And in the second perception, we have that data is complex, and we have data organizations that exist, but it's very dynamic, and the storage is unlimited with multiple shapes. No matter where you are moving or where you're coming from, in any of those perceptions, you might fit well, or you might disagree, and the intention is not to create this ambiguity. The intention is to create clarity. So data spaces can rely on technologies from a very basic one, which is a database, which is characterized by collection, storage, organization, structures, and a language. And as you may know, it's a query language that we need to access the data. In fact, these 5 characteristics classify a data space. But then when we go into data warehouses and data lakes is when the ambiguity becomes to be more complex, and even people are now using these terms indistinctly. But the most relevant part in these differences is that there are large amount of data, historical data in the data warehouses, and there's a management system on top of that that satisfies specific business needs. And here is when we go into this discussion of specific domains. But in the other side, we have the data lakes, which is more an information system that allows to use more structural and non-structural information. And then this performance is precisely focusing analytics, and most important is allowing us to use machine learning techniques and real-time processing. You see, there is a very fine-grained differences that we should be careful when we talk about these data spaces. And then there's also a new area or a specific area in data hubs, when we just have collection of data that allows multiple organizations to access and distribute. The main purpose of data hubs is more like sharing and obviously distribution. We're talking about technologies. We're not talking about conceptual aspects in here. But all across these data spaces characteristics, we have a common aspect. All of them are looking towards offering data as a service. And here's when IT market comes into this game. So the data revolution is a transformative actions that requires technologies in a context of a business ecosystem. And obviously the data is the main element to produce, to be used, or to be sold. And this is when we are now in the commission or even in the evolution of these solutions towards selling the data, empowering the data towards the owners of the data. And of course, this context or this single digital market is the main element to materialize that. And you will not believe, but now we have the data revolution. Everybody's talking about this. Everybody's designing platforms. Everybody's proposing solutions. And on the other side, we have this data space as a growing element to satisfy this data revolution. But we still have a missing gap. And this missing gap is what we call the data marketplace. And it's not my quote, but there are some publications, some research firms that they're saying that the missing piece in a modern data architecture is this data marketplace. And I don't doubt that even in the report from OpenAI, they have in some parts the data marketplace, but they are not considered yet as a crucial part of this data space. Why it should be considered crucial? Because of course we're talking about this monetization, commercial value, even empowerment. And I will not obviously go into this Pitney Bowes report, but if you just look at the bottom part, the 81% of the businesses are now turning on online data marketplaces. And this is precisely why data spaces without a marketplace will not succeed. And aware of this one, in IT market, we have done extensive analysis. We have gone to the most relevant marketplaces that exist in 2015, 14. And this is just a summary of one of those that has been already successful. Success stories, some of them are not successful yet, or some of them even fail in the process of providing this data. These are just reference to us in IT market to build what we call the data marketplace generic model. Obviously, this is not the intention to create a standard, it's just the intention to contribute to different communities like the IDSA or the different communities, and then define for the first time and contribute more than define the different elements, the different stakeholders with a data-centric approach. And this is the most important in IT market, the data-centric approach. Obviously, I don't have time to go into the details, but keep in mind that this model is accessible, it's open, and is described in our public deliverables. We have also created what we call the data lifecycle process from collection, accessibility, storage, utilization, and for the first time, we have introduced the selling part, a price model, a revenue model, offering descriptions, and provider models to precisely satisfy these needs from the different marketplaces, from the different data spaces. And obviously, the formulation of ontology, what we call a formal process, is one of the main outputs or contributions that we want to bring to this community as well. So there is an ontology which is called Occasus that reflects and integrate all these terms following also standard models like VCAT from the European Commission. So we are not reinventing here ontologies, we're not inventing vocabularies, we're reusing the most and bringing communities together to define what we call the vocabulary for the marketplace. Now, if you see the central part of this image is precisely the IT market stack. So because we are an innovation project and we have industrial partners, so we have built what we call our backplane data model, our APIs, as traditionally now is very popular open APIs approach. We have some pilots to verify and validate our approach, our implementations, and obviously we have marketplaces as front ends to verify that we are able to connect data revolution or data solutions, data spaces with marketplaces. And of course, the top of this stack is the data as a service, as I mentioned before. Is the main objective of what we call the so-called the data revolution today. Excuse me. Then in the very central part, you also see attributes, and these attributes are coming from this Intereconomics journal. I think it's one of the reference journals in data monetization, data economies. And on the left-hand side, you see our mapping with the values of the IDSA, which is the data sharing and data infrastructure. Up to today, we are in the first year, well, 18 months running, and we're still identifying which kind of connectors we can contribute to this data sharing infrastructure to provide them as a contributions as well. So at the moment, we are focusing in developing our own, let's say, architecture, implementing reference architecture. So we have some core backplane functionalities based on these requirements that we identified. We have created the concept of artifacts, software artifacts that basically can be maybe transformed into connectors. We have some artifacts that are going to be publicly available. Some other ones will be a backend. And at the end, we will have what we call the backplane to support marketplaces. We are not building one more platform. We are not building a marketplace. We are supporting any marketplace that requires some functionalities, and we are building APIs and sub-services behind those APIs to support that. The result, instead of going into this big complex diagram, I decided to go into this kind of a fair approach. So findable, accessible, interoperable, and reusable layers. So you have from the right, the infrastructure is in a very gray area. Don't worry about that because this is something that is computer infrastructures. You don't have to care about that. What you have to pay attention is on these artifacts. Those artifacts that will provide some services. They will be running services that you can connect via APIs, open APIs, specification. No open doesn't mean free, just means standard specifications. And then you can connect via our WebRIs or SDKRI. We have developed a software development kit to interconnect to those APIs. So developers does not have to learn everything about the project, doesn't have to learn everything about each API. They just need to connect to the SDK, a constructor, and they can connect dynamically to these services. And not necessarily all of them. So they can select from the different services and select the ones that satisfy to empower or to enhance what we call any marketplace on the left-hand side. So the blue part is more or less the accessories, just to demonstrate that our IT market backplane is valid and is let's say, useful. And the green part and the kind of the greenish light green is the main contribution in our assets. So we're in a very ambitious environment or pilots because we have the automotive, well explained before. We have the industrial manufacturing, Industry 4.0 or IoT, industrial manufacturing, and we have also the well-being and AHA domains. All the data coming from these domains, we have already created some sort of marketplaces to test and validate with our APIs if all the data that's coming from these domains can be integrated, and most important, can be commercialized. So these are the main objectives or the main assets to prove in our project. Obviously, we will have a public release of our open source project. At the moment, we have it in our Git. For me, it was very interesting to attend also today the session at 12 when they are proposing also the Eclipse / IDSA repository. So we will continue analyzing these possibilities. At the moment, we have our own project as open source, but we're open for any collaboration. Most important to contribute our projects, our softwares, to brand it or to even contribute to different solutions in the context of these communities. Just the last slide is to say that intelligence comes from these APIs that are going to be easy to access, and via the SDK can be, let's say, automatically or semi-automatically accessed. Interoperable because we're using, as I mentioned before, these standard vocabularies and data formats that are more or less across different domains. Integrative because we are following this open API approach, standard approach, rather than just components. And then we have what we call the trusted and secure software tools because we have all this security privacy by design in our approach, in our IDMs, and we are also open 008 2.0, standards that everybody manipulates, everybody knows, and particularly that are very well tested and secure in the industries. This is just the list of partners, as I mentioned, lead partners in the industry, lead partners in development, and of course, pioneers on research, academia, and research organizations. I'm happy to present, and thank you, Sergio, again for this challenge, because you gave us only 10 minutes to present many aspects of the project, and hopefully I achieved to at least give an idea of what we are doing in IT market. Thank you.
Okay, thank you so much, Martin. And I think that you gave us very good information about design principles for data marketplaces, and the fact that the data spaces should be linked to a business objective, to a business benefit, and the data marketplaces are giving this opportunity to all the industry to valorize their data spaces in order to be exchanged and shared. Now we pass to another project, and Benjamin, you are going to present the trusts project. The floor.
Yeah, that's right. Thank you, Sergio. Okay, so all right. I hope the screen sharing is working.
It's fine. It's fine.
Yeah. So let's put that up there. Okay, so then, yeah, I'm going to give an overview of the trusts project. I am the technical lead of the project, and I'm going to focus on the mission and the general properties for it, and then I'm going to give an overview of the lessons learned in the project, a short overview. All in all, yeah, I have to try to stay under the time limit, of course. So the Trust project is built on the experiences and the technology of 2 European data marketplaces that came before the project, right? So this is one of the important things, that it's not built from scratch, but it is built on international data spaces, which should be clear for everybody here at the event. So that's from Germany. And then we have the Data Market Austria project from Austria. And one of the central tenets of the Trust project is that data sovereignty will become a critical success factor for data sharing, especially in Europe. And so the novel developments in the Trust project are additions of approaches for enabling and also maintaining data sovereignty. And I'm going to talk a little bit on the next slides also about what that means, right? Where we're going beyond what most other projects are doing currently. There's also a strong foundation for data governance based on semantic technologies. And then finally, it's also designed for interoperability with other data marketplaces. So it's not a standalone data marketplace. So yeah, in addition to that, there are several unique selling points of the platform if you look at it from a more technical point of view. So the first one is that it's security and privacy by design. It empowers consumers to protect their privacy while at the same time enabling the emerging data economy. And so the way that it empowers consumers is by providing enforceable guarantees. One of the way that you need to think about that is that it's possible to not have plain text data being transferred, but having a representation of the data being transferred. It could be statistically changed, or it could be using cryptography. And this representation of the data can only be used in certain ways. And that allows enforcing these guarantees for privacy and also for security. In addition, it's innovative beyond the state of the art because not just data sets can be traded, but in addition, the access to services and portable applications can be monetized. It's based on an architecture that has strong elements of distribution, and so that the infrastructure components are not run, they don't have to be run in one central place. That also allows for scalability and extensibility. And then finally, it's future-proof because of compatibility with all the high-level principles of Gaia-X. So here's a quick overview of the trust architecture. We have different types of nodes that run different kinds of services. And basically, organizations that want to participate in that ecosystem, they can run certain infrastructure on their own, which allows them to plug into the ecosystem with their own services and applications, basically. So I can come back to this later if there's questions. And then this is a schematic overview of basically how different organizations can run different infrastructure components from trust together with their own services, and then connect to each other via the so-called trusted connector via an untrusted infrastructure such as the cloud. So then here's a quick overview of how the different trading capabilities of the platform relate to capabilities that are required for Gaia-X alignment and compatibility. So in particular, we have data trading. So you can think of that as basic file access. We have trading of services, of access to services. That's basically like accessing a database or accessing other web services that you know today. And then there's the more novel idea of app access. And in Trust, we're strongly emphasizing the idea of having app access with usage control, which I believe is most closely related to the Gaia-X concept of high assurance levels. And in the IDS reference architecture model, there's also a similar concept. So that's a high security level, I believe. Okay, now, let's go back to the idea of data sovereignty. And the important thing is that if you look at it from an IDS perspective, there's different ways to achieve data sovereignty. There's legal contracts, there's certification, and there's technical means. Some of the most well understood ones right now in the category of the technical means are authentication and authorization. This is very well understood for more than 10 years. Usage policies is a bit less well understood, but there's a lot of research on that. And then there's the idea of usage enforcement. And this is a relatively novel concept on which we're capitalizing in trusts. And we're doing this by adding cryptographic and statistic approaches. Right, this includes, for those that are a little bit more familiar with those ideas, technologies such as multi-party computation, homomorphic encryption, differential privacy, and anonymization is basically one of the bread and butter technologies in this area. Okay, so that's kind of the background that I wanted to talk about. And now I'm going to switch to basically what the tech lead, so me and Christoph Lange, us as the tech lead from Fraunhofer Fit, what we have learned in the project so far. First is basically mission statements that we have been refining over the course of the project. The first one there is that we feel validated saying that data sovereignty can unlock the value of data which currently cannot be shared, right? So a lot of data which is personal or which is otherwise hard to share in current approaches, that actually requires data sovereignty and different ways to guarantee and enforce it. That's why we believe that data sovereignty will become a critical success factor for data sharing. And then importantly, that's why we believe that the GDPR will become a location-specific advantage of Europe, right? Because in many other economic areas in the world, nothing like the GDPR exists. And we can see right now a move in some places to kind of copycats to adopt several factors of the GDPR, but usually not everything. And even in the US, they're now discussing, cherry picking some parts of the GDPR. And yeah, it's a very interesting time for that. And I believe that in Europe we can say, well, we have the original, right? So we have the most experience with this. It's not that much experience, of course. It's just around here for a few years. But I think we are leaders for this in Europe. And then finally, because of these first 3 points, trust will enable data marketplaces with enforceable guarantees for data sovereignty in Europe. And that's what we're trying to do in trusts. Now then, if I would try to phrase in a very concrete way the lessons that we learned so far. The first one, let's say, is more of a technical statement, and it's also why I believe that open source initiatives in the area of data spaces are very important, is that every data marketplace needs a strong foundation in terms of the software which is used to implement the infrastructure. Then beyond that, there's a lot of data which goes beyond non-personal data, right? And so, for instance, if you talk about industrial data spaces, you can go very far and you can address a lot of use cases without looking at these data types. But if you want to exploit some of the most interesting use cases that would be really strong arguments for using data spaces to monetize data sharing, then you need to address the following kinds of data, right? That's sensitive data, most importantly, like medical data, personal data. You can think there of something like social media data, regulated data. There's a lot of that in a lot of places. For instance, financial transaction data is very highly regulated. And then finally, there's just the whole idea of confidential data, right? That some companies want to do some computation together with data which is purely confidential, right? You don't even need to think a lot there about laws. It's just confidential. And they're not going to share it if they don't have strong guarantees. They would rather not share it, right? This is the important thing in a lot of these cases. If it's easier to not share it than to share it, that's what's going to happen. So you need to make it easy to share that data. Finally, if we come to some bread and butter approaches in this area, such as anonymization, then even these old technologies that are around for decades, anonymization is here for almost 30 years, the legal specifics are still not sufficiently defined. And if you go to other privacy-enhancing technologies, it's even worse regarding legal support, right? So even if you have the technologies, there might still be important legal aspects that make it hard to use them in practice. Okay, that's it from my side. And then I give the floor back to Sergio.
Thank you, Benjamin, so much for this consideration, especially those about to go beyond non-personal data and the need to manage them in a marketplace. Last but not least, Juanjo Hierro from Firewall Foundation and the project I4Trust.
Okay, thank you, Sergio. I'm going to share my screen. I hope you can confirm everything is doing okay. Now in full mode, hopefully.
It's fine, thank you.
Yeah, thank you. All right, so I'm going to introduce I4Trust, which is one of the flagship projects we are running within the Firewall community in partnership with also relevant organizations quite well positioned in the data space arena, as it is the iShare Foundation. Mission overall is that of boosting development of innovative services around creation of new data value chains. That's what we believe data spaces are all about. And well, the vision how we are going to achieve this is by bringing a very concrete, mature framework that will enable creation of data spaces. Very interestingly, and I will elaborate a bit more later on, a framework that is available now and that allows to create such kind of data spaces that will boost development of these kind of innovative services. Values in the DNA of this project and trustworthiness and sovereignty, of course, in the data exchange, but very important, the effectiveness of data exchanges and how to enable creation of value around data and therefore the ability to create incentives for business to share data and grow. Aspects like the cross-domain element, the cross-domain approach we are taking. We do not believe about data spaces on concrete domains, but really frameworks that can work cross-domain, because this will foster quite more innovative services. And very important, openness, open standards supported through open source. Max already brought the reference to the Open Day white paper, Design Principles for Data Spaces. And I think I agree, it's actually a good reference. I wanted to bring here the taxonomy of building blocks that is pointed out in that white paper. We have been quite active in contributing to the development of that white paper, and particularly when designing this taxonomy of building block. And actually, when we present the taxonomy of building blocks we are implementing in I4Trust, we bring exactly the same picture, the same taxonomy of building blocks. More colorful, if you wish, but if you go building block by building block, exactly the same ones, because it's really about creating consensus, what is needed, and now moving to the next step, which is actually implementing and making it happen. That is what I4Trust is all about. So what, let's say, distinguishes us from what is defined high level in that white paper on design principles for data spaces is that we go and adopt concrete technologies for each of these building blocks, because it is all about materializing, making it happen. And we are very high level. I will go in a second, but very high level, we bring best of the breed technologies coming from two communities, two organizations. On one side, Fireware, where we are bringing an open source implementations for each and every of the individual elements that cover the building blocks that are necessary for creating data spaces, and in combination with iShare Foundation, which brings a solid design for what would be the framework for supporting trusted data exchange, identity and access management. We like it a lot because it was based on the same standards we were adopting for identity and access management in Fireware, but bring in addition elements for trusted data exchange. So we found that this nice combination could be a killer in that space. And last but not least, they bring quite also mature elements for what refers to data space governance, and where you need to set up legal frameworks for business agreements for supporting the kind of operational agreements that are needed in data spaces. What is the approach and the fundamental principles followed in I4Trust, and in general, what we are pushing within Fireware when we talk about data spaces is there is a fundamental principle to preserve, which is every participant, when they publish data, may not know a priori who is going to consume the data, and therefore it's quite important to establish how you share the data, what is the API, what are the vocabularies, what is the concrete standard for identity and access management. Same when a participant joins the data space, there should be mechanisms, standard mechanisms, how to discover what data resources exist and how they can be consumed. This means, among other things, in the first place, to agree on a common language that every participant speak. That means defining a standard API for data exchange, standard data models, and common mechanisms for identity and access management. And this is what I4Trust brings, very concrete, because in I4Trust, everything will be around exchange of digital twin data. And for exchange of digital twin data, we rely on NGS-ILD, which is becoming more and more a de facto standard for getting access to digital twin data. Digital twin data models coming from the Smart Data Models initiative that is growing as we speak, with more and more data models being adopted in different projects, and a solid identity and access management framework that supports trusted and secure access to the data. And last but not least, a number of global services you always need in data spaces. Martin was mentioning marketplace are something you need to put in place if you want data spaces to really flourish and take off. I fully agree, but we have technology that works and relies on quite solid standards. This is focus the zoom on the technology building blocks and the reference to the standards we do adopt. NGS-ILD, JSON-LD, as we were talking about, OpenID Connect, OAuth, JSON Web Tokens, for publication discovery, DCAT AP, for marketplace, TM4 Open APIs, which is a reputed industry body which has been working on that space during many years and engaging all the telecom sector in that space. And very important, alignment with Connecting Europe Facility building blocks. These are, for instance, IDS, a context broker technology for the data exchange, or the European blockchain service infrastructure. Around this technology, we are creating a community, and we are running open calls which will support the selection of SMEs which will run experiments using this framework. And this will start this year. Very important, I4Trust. We found that there were a number of projects that were well aligned in the vision we were bringing and agreeing on collaborating with us in creating a more solid framework, even incorporating and working all together. The projects like I4Trust I'm representing here, but BD for Energy, EO Hubs for Data, Platoon Synergy. We decided to create an initiative of collaboration we call Frontrunner Data Space Initiative, which essentially is going to focus on materialization of this common framework that is needed for creation of data space, with a number of baseline technologies to adopt. And we understand there might be and approaches, but we want to really focus on delivery and the short term, and that's why we choose make some choices. This is an initiative that is going to be supported not just by this project, but by organizations like the Firewall Foundation, the Big Data Value Association, International Data Space Association, and the own iShare Foundation. Components that we aim to bring for the support of creation of data spaces are now part of new releases of Firewall. With Firewall Release 8, we have created a specific section on what components from the Firewall catalog you can use for creating data spaces. Here you will find, for example, implementations of the IDS connector the context broker, of course, and identity providers, marketplace services, etc. And this over time will be curated, and we will come with recipes how to integrate the different pieces for creating data spaces. I also would like to take the opportunity to advertise the white paper we recently delivered on data spaces, which very well aligns with the one from OpenDay, but elaborates on how to materialize this using concrete technologies. Last slide to conclude. Main message: it's time to execute from our point of view. There is already mature components, some coming from iShare, coming from Fiverr, that are good examples how we can make data space happen this year. There are already a number of projects bringing the necessary resources for supporting first use case experiments. And that is actually what is behind this ambitious frontrunner data spaces initiative that has been kicked off. Ingredients for success we should not miss from my perspective is the alignment with the European Commission with regards to the Connecting Europe Facility digital program. We think we are very important aspect. The unique integration of digital twin concept and data space, I think, is going to bring a genuine element and distinguishable aspect, which may pave the way for success. And well, we look towards how GaiaX could benefit of all these efforts and moving forward all together. Thank you.
Thank you so much, Juanjo, and thank you so much to all the speakers. Just a conclusive statement from my side. So we have learned a lot from the experience of these 4 projects and the European Commission. And the 3 main ingredients of a data space that is high value, accessible, interoperable, usable data sets, the industrial and also personal data platform, and the business and governance rules have been, in my opinion, all touched and all addressed by these 4 projects. And so this is a good heritage for the next actions. Just one announcement is that the OpenDI project is now organizing a second iteration of the task force about data spaces, and the focus will be mostly on maturity. And the fundamental point is that we have all these technologies, but the point is, are these technologies mature enough, for instance, to be deployed directly in the Digital Euro program? And on the other side, is the demand side of data spaces well prepared and ready to fully adopt and exploit all these potential of the data revolution, data marketplaces, and data spaces? This is something that we are going to address in the next weeks in the OpenDI project. Thank you to IDSA. And I conclude here, and I see Lars, which is eagerly waiting for my conclusion, and I will conclude. And thank you so much for your attention, and thank you so much to the speakers.
Thank you so much, all of you, Sergio, for guiding us, and all of you, well, dear colleagues from the different projects, for all your insights. And I would like to stress once again, I think your contribution to the next version of the Design Principles for Data Spaces paper is more than needed. And I will also put it in the chat. I would invite those who are currently not into this group to participate and to add your content. So we will get in touch with you. I'm looking forward to that.